Okay, so how to verify identities. So how to verify identities. Okay, so step 1. So work down only one side of the equation. So work down only one side of the equation, with an emphasis on one, if I write that correctly. So one side of the equation. Arriving at the end to the other side. Other side. So what do I mean by this in effect? I.e., we cannot assume what must be shown is true. We must prove it is true. Okay. So number 2. So always choose to simplify the more complicated side. So always choose the more complicated side. As it's easier to simplify than complexify. And I don't know if that's a word, but that's okay. Complexify. Number 3, use known identities to simplify. So use known identities to simplify. Number 4, if all else fails, I guess. So if all else fails, and this is indeed if all else fails, translate all trigonometric functions into their equivalent expressions in sine and cosine. Expressions in sine and cosine. Okay, so what do I mean by all of this? Let's actually do an example, or a few examples rather. So example, let's verify the following identities. So verify, meaning prove, the following identities. That's a terrible D. Identities. Okay, so number 1, let's say we have quantity cosecant of theta plus 1 times the quantity cosecant of theta minus 1 is equal to cotangent squared of theta. Okay, so it appears to me that the left-hand side is the more complicated side, so I'm going to start there. So rewriting, I'll have cosecant of theta, no, cosecant of theta plus 1 times the quantity cosecant of theta minus 1 is equal to, and I'm not going to set it equal to the right-hand side because I don't know that it's equal to the right-hand side. I have to show that. But I notice that this is of the form for the difference of squares. That is, it's cosecant first guy squared, cosecant squared theta, minus second guy squared, 1 squared. Okay, so simplifying, this is just cosecant of theta minus 1. But I have an identity. I have the fact that cotangent squared theta plus 1 is equal to cosecant squared theta. So if I were to subtract 1 from both sides, do you agree that this would be cotangent squared theta? Which is exactly what I wanted to prove. Check mark. I've done it. Notice that the very last step is the right-hand side of the equation. If you can get the right-hand side of the equation, you've proven it, provided all of your steps are sound logically. Okay, so number 2, let's say we have sine squared theta times cotangent squared theta is equal to 1 minus sine squared theta. So for me, it looks like the left-hand side is more complicated, so I'm going to start there. So I have sine squared theta times cotangent squared theta is equal to, and I do not set it equal to the right-hand side. But what is cotangent squared theta? If I rewrite this on the right, so sine squared theta, cotangent is really cosine squared theta divided by sine squared theta, which means I can reduce the sine squareds, and I'm left with cosine squared theta. But I have my Pythagorean identities again. And the main Pythagorean identity is cosine squared theta plus sine squared theta is equal to 1, right? So do you agree that if I subtract sine squared from both sides, that is, I get cosine squared theta is 1 minus sine squared theta? So I can rewrite cosine squared theta as 1 minus sine squared theta, and that is the right-hand side of the equation that I was looking for. So check mark. I've established the identity. Okay, let's do one more in this little, well, no, not one more. Let's do a whole bunch more. So number 3. Let's say I have cosine of theta divided by 1 plus cosine of theta, from which I'm subtracting cosine of theta divided by 1 minus cosine of theta. And I claim that that is 2 cotangent squared theta. Once again, I claim that the left-hand side is the ugly side, so I'm going to start there. So cosine of theta divided by 1 plus cosine theta minus cosine of theta divided by 1 minus cosine of theta. So I can get a common denominator here. I have 1 plus cosine of theta times the quantity 1 minus cosine of theta. And in order to do that, I need to take the first fraction and multiply him, top and bottom, by the denominator in the second, that is 1 minus cosine theta, from which I'm subtracting the numerator of the second fraction times the denominator in the first, which is 1 plus cosine of theta. Basically, I'm just getting the LCD. Okay, so distributing on top, I will have cosine of theta minus cosine squared of theta, then minus cosine of theta minus cosine squared of theta, all over. Well, the denominator is the difference of squares. So it's the first guy squared, 1 squared, minus the second guy squared, cosine squared theta. Okay, so notice that cosine of theta minus cosine of theta goes away. So what I'm left with in the numerator is negative 2 cosine squared thetas. And in the denominator, I'm left with 1 minus cosine squared theta. So once again, I go back to my main Pythagorean identity, which is cosine squared theta plus sine squared theta is equal to 1. So I notice if I subtract cosine squared theta, I get sine squared theta is 1 minus cosine squared theta. So I can replace the denominator here with sine squared theta. So I have negative 2 cosine squared theta divided by sine squared theta. Well, cosine over sine is cotangent, so this is negative 2 cotangent squared theta. Now, is that what I wanted? Oh, did I have a typo? I did. There's supposed to be a negative. Yeah, typo. Check mark. Had I written it down correctly? Yes. Okay, so moving on. And you can tell if you did something wrong because I got the wrong answer from the right answer, so I knew I wrote it wrong. Okay, so number 4. Let's see, let's prove or establish the identity. Let's do cosecant to the 4th of theta minus cotangent to the 4th of theta all over. Let's do cosecant squared of theta plus cotangent squared of theta, and I claim that this is 1. Well, clearly the left-hand side is a complicated side. So let's start there. So we have cosecant to the 4th of theta minus cotangent to the 4th of theta all over cosecant squared theta plus cotangent squared theta. So remember, I can't set it equal to the right-hand side. I have to prove it's equal to the right-hand side, but I claim that in the numerator, what I really have is cosecant squared theta quantity squared, because that's when you raise a power to a power, we multiply, and 2 times 2 is 4, minus quantity cotangent squared theta squared, which will give me the 4th power, all over cosecant squared theta plus cotangent squared theta. So in the numerator, what I have is the difference of squares. So I can factor it as first guy, which is cosecant squared theta, plus second guy, cotangent squared theta, times the quantity, first guy, cosecant squared theta, cosecant squared theta, minus the second guy, cotangent squared theta, end parentheses, all over in brackets cosecant squared theta plus cotangent squared theta. We'll notice that this first factor reduces, leaving us simply with cosecant squared theta minus cotangent squared theta. Okay, what was the Pythagorean identity involving these? Well, it was cotangent squared theta plus 1 is equal to cosecant squared theta. Why do I keep on missing the C there? Cosecant squared theta. Okay, so do you agree if I subtract cotangent squared from both sides? I'll have cosecant squared theta minus cotangent squared theta. So I can replace cosecant squared theta minus cotangent squared theta with its equivalent, which is 1, check mark. So it does work. Okay, let's do another one. So number 5. Let's see, let's establish the identity quantity secant theta plus tangent theta all squared. I claim that that's equal to quantity sine theta plus 1 squared divided by cosine squared theta. So now in this case, it looks like the right-hand side is a more complicated side. So I'm actually going to start there. So I'm going to start with sine theta plus 1 quantity squared, all divided by cosine squared theta. Okay, so remember, when you square something, that means you're multiplying him by himself. So sine theta plus 1 times the quantity, sine theta plus 1, all over cosine squared theta. Foiling, what I get in the numerator is sine squared theta plus 2 sine theta plus 1, all over cosine squared theta. Okay, so I'm going to break this up into sine squared theta, because it's a common denominator, that cosine squared theta. It belongs to everything in the numerator, plus 2 sine theta divided by cosine theta times cosine theta, that's what it means to be squared, plus 1 over cosine squared theta. Okay. Well, sine over cosine is tangent, so I claim this first term is tangent squared theta. Plus 2 times, well, sine over cosine is also tangent theta, but 1 over cosine, if I take that second cosine, is secant theta, plus, and once again, 1 over cosine is secant theta, so this is secant squared theta. So this is of the form a perfect square trinomial. It's of the form first term tangent theta plus second term secant theta, all squared. Check mark. We've proven it, or established the identity.